Today in the series of AZ-303 Microsoft Azure Architect Technologies exam, we are going to discuss about virtual network. So what is virtual network and why it is required? So before going to discuss about virtual network, we are discussing about the need of virtual network. So in Azure, we can provision many resources like SQL Server, storage account, virtual machines, etc. We can provision n number of resources. But if we are not having some kind of connectivity into those resources, then those resources are like stand still, and there is no use of those resources if we are not able to communicate one to another. So providing some kind of communication between those resources, we require some kind of network, and that network is called Azure Virtual Network. Let's see the definition given by Microsoft. So virtual network, and short it is called as VNETs, are used in Azure to provide private connectivity between Azure virtual machines and other Azure services. Looks like very simple and straightforward definition, but there are so many important points here to discuss. So virtual network, the first point is in the virtual network, the first point here is the private connectivity. So the virtual network is using private connection between Azure virtual machines and other Azure resources. So that means this virtual network, when we provision it, it is providing only private connectivity between all Azure resources. So that means these resources which we are provisioning, they use virtual network to connect to each other, but they don't have a capability to connect to any other machine or any other services which is outside of Azure, or we can say outside of this virtual network. In the starting, virtual network providing only private connectivity between Azure resources. So I hope you understand very well that virtual network is totally securing all the connection in between ourselves. So nobody else outside of the virtual network can connect to any resource provisioned inside this virtual network until unless we are not allowing anyone else to connect. Okay, let's go to the next point. So let's discuss about some basic concepts in VNet. So what is address space, what is subnets, what is region, and the subscription. So let's discuss about it in just a second. So address space, you have seen many times. We need to we used to define some IP ranges like we used to define something like 10.10.10.0, something like that. So this is called IP, and if we slash it with something like 60, then it is called all address space, or we also call it like cider range. Okay, so why it is like what does it mean by 10.10.10.0/60? What is it? So it is something like that we have four spaces: one space, dot second space, dot third, and dot fourth. These four spaces are there. Yeah, this is a dot kind of thing. And how many at each space, how many digits are allowed in 0 and 1. So it's kind of binary notification 0, 1, 0, 1. So here we used to define 8 0, 1 digit. Same goes to here 8, 8, and 8. It is IPv4. It is IPv4. So total 8 plus 8 plus 8 plus 8. That means total digits here are 32. So we are using those digits here as 32. And now here, if you want to calculate 2 to the power 8, so 2 to the power 8 will be 256. That means total 256 IP will be allowed at this one box. This box, total 256 IPs are allowed here. So that means from 0 to 255. Total number of IPs is 256. So here from 0 to 255, same goes to here, 0 to 255, and same 0 to 255, 0 to 255 allowed. Now, for example, I am writing here one IP called like 10.10.10.0/24. So what does it mean by 10.10.10.0/24? That means 24 digits out of these 32 digits are rigid, are static, are not changing. So 24 means 8, 16 and 24. These digits are static digits, so these are not going to change. So we can change only this location we can change. So that means we can change 8 digits out of 32 digits. So if we are going to change 8 digits out of 32 digits, that means we can add 0 to 255, any IP out of it, we can put it here. This is 10.10.1 is static, we cannot change anything into it. But here we can put 0, 1, 2, 3, 4 till 255. So this is called address space. So this is address space. Now I hope you understand very well. For example, let me give you one more example, 10.10.0/16. So 16 means now this is a static, this is a static, okay, and this is now dynamic IP. So here we can add 0 to 255, and here also we can add 0 to 255. So total number of IPs provided here are 0 to 255 here and 0 to 255 here. So there are approximately 2 to the power 16 IPs are present for this side array. Now coming to the subnet. So for example, let's take this. This is an address range, and we are going to create a VNet with this with this address range. So subnet is something like enable you to segment the virtual network into one or more subnet. So for example, now you have this this range for your VNet. So we can create IP range for subnet, something called like in between this. So in between this can be 10.10. So this is 16. So it should be like 0. It should be 0, 0, then 16. So 10.10. Here I have choose 0.0/24. Another subnet we can create here 10.10.1.0/24. So here I'm changing this IP, the second location IP 0, 1, 2, 3, 4, and we can create n number of subnets out of it. We can change here also. For example, here I'm writing like 1, and then I'm writing like it's only 2 to the power something. We cannot put like 1. We have to put something 2 to the power something like 0, then 2, then 4, and then only we can define the next IP ranges for our subnet. So any VNet which we are going to create require a address space, and for creating resources we need to create subnet inside those VNet. Now coming to the reason, every VNet is confined to region. Every VNet. So that confined to VNet means confined to region means that VNet is cannot be moved from one region to another region. So that means if you created a VNet called VNet 1 inside, let's take example like West Europe. So if you have created your VNet inside West Europe, you cannot move this VNet from West Europe to US or Asia or somewhere else. You cannot move this VNet from one location to another location. Same goes for the subscription. So VNet cannot be moved between the subscription as well. So these are scoped inside region. These are scoped inside subscription. Now, one more thing, just want to add you here. When I will go give you demo on address space, then I will show you that part. So here we are defining only one address space, but for any VNet we can define multiple address space. Right? I have created one VNet with this address space, but also added something else like 172.0.0.0/24. So we can add multiple address space also. We have to keep in our mind that whenever we are going to create subnets, we should choose subnet something like that. It should not cover whole IP ranges of the field. So we should choose subnets very precisely so that it will leave space in the future requirements. Also, there is one more recommendation here, like if we are going to create a VNet, we should also follow to have large VNet as comparison to multiple small VNet. Why it is necessary? So if we have a large VNet for our organization, then we don't have to provide some special kind of connectivity between multiple VNets, so that if many resources are created inside this VNet, they are visible to each other automatically. So we have to think these things into our mind. Now let's go to the next slide. Okay, communication with on-premises resources. This is very important. Right now, we used to have VNet in our Azure cloud, public cloud, but how we are going to connect those resources, how we are going to connect our VNet from on-premises environment. So from on-premises environment, we having these three concepts called point to site, virtual private network, site to site virtual private network, and Azure Express Route. What is this? Let's discuss it. So point to site virtual private network means there is one point called computer. It can be your personal computer, your office computer, something like that. And now you are going to connect to your VNet. So this is called point to site. That means single computer is going to connect to your VNet. It is called point to site. Site to site means when you are having your on-premises VNet, and now you want to connect this on-premises VNet to your Azure VNet. So when we are connecting VNet to VNet, it is called site-to-site VNet. So this VNet can be your on-premises VNet, and this VNet can be your Azure VNet as well, or also can be your other cloud VNet as well. Now coming to the Express Route. So Express Route is something similar to site-to-site VNet, but here we are using VPN gateways. Here we are using VPN gateways where our connection between on-premises and cloud VNet is going under private network. It is not Microsoft network, but it is something private network. So how it works, like from your private on-premises VNet, some express route provider like Vodafone, Airtel, there are so many other express route provider. They used to provide those kind of service so that you can connect your VNet to find me location. Find me location of Microsoft. So we have one location, find me of Microsoft. So the connection between on-premises to this site provided by some kind of third party, and from here find me location to your Azure VNet will be done by the Microsoft backbone. So this kind of connectivity will be done by the Express route. Let's go to the next slide. Now, what kind of filters we can apply on our network traffic? So we have two kind of filters. One is the network security group, also called as NSG, and another one is the network virtual appliance, which is NVA. So what is NSG and what is NVA? So NSG is a kind of rules. We used to apply those rules, like for example, we have a VNet, and I want to restrict all the traffic from all other environment except one VNet. So I will write some kind of rules so that it will stop all traffic and allow only one traffic from a particular VNet or particular VM, particular IP or particular port. And then we are going to assign this NSG to a subnet. So if this subnet is having multiple NIC card, so and NIC is something like this is the one which is used while assigning the IP. So all the IPs will be assigned on network interface card. So if the subnet is having multiple NIC card, so automatically this rule will be applied on all the NIC. Also, we can assign this rule directly to the NIC card. But I hope that is not good. And I suggest you to have some kind of a special subnet so that we can apply these rules on the subnet level, and automatically it will apply on the following NICs. It is easy to handle. So if we are going to apply rules on particular NIC, then I don't think it is very good. Otherwise, we have like 1,000 NIC card or 2,000 NIC in one subnet, and then we have to check each and every NIC. So better to apply these rules on subnet level. so that we can organize it very well. Now coming to network virtual appliance. So network virtual appliance is kind of virtual machines. So for example, you have your VNet here, and now your VNet is going to connect it by a special kind of VM, which is called NVA. That means Network Virtual Appliance. And now this NVA is connected to public cloud or public network. So whatever the traffic going and coming from public network to our VNet is coming through NVA. And now in NVA, we used to have our firewall rules applied. We used to have our, if we want, we can apply our NSG as well over here on the NVA. There are so many other protected tools are applied here which can protect our VNet and our resources which are present in our VNet from attackers from the public internet. So this is called network virtual appliance. Coming to the next slide. Now we are going to discuss about the virtual network peering. So what is virtual network peering? So for example, here we already have one VNet here and one VNet here. Or as per Microsoft definition, whatever the resources we are going to create here, these resources are not visible to any other VNet. So if we want to connect these resources from here, it is not allowed. It is visible only inside this VNet. So now if we want to allow some other virtual network to connect to my first virtual network, how we can do it? We can do it by peer. If we create a virtual network peering between this VNet 1 and VNet 2, then whatever resource we are going to create here in VNet 1 will be visible to VNet 2. Very easy. So this is called virtual network peering. There are two types of virtual network peering. One is virtual network peering normal. That means you are going to create one virtual network in West Europe. I'm always taking example of West Europe because I'm located here in Budapest. So this is the nearest location for me. So I used to take it. But you can take any location. And another VNet is also created inside virtual network West Europe. So if both the VNet are created inside West Europe, and we used to create a network peering between them, then it is called virtual network peering, which is a normal default peering. Now coming to the second one, which is global virtual network peering. So if we have one virtual network in your West Europe and another one in East US. So if you want to create a virtual network peering between these two virtual networks, then it is called global VNet peering. That means this is location 1 and this is location 2. So if we are going to connect two virtual networks from different locations, then it is called global virtual network peering. Continuing the same, virtual network peering is non-transitive. What does it mean by non-transitive? Non-transitive means if A virtual network is connected to B and B virtual network is connected to C, so A virtual network is not connected to C. It is not transitive. If A virtual network is connected to B and B is connected to C, that doesn't mean that A is connected to C. For connecting this A to C, we have to define peering between A and C. Then only A will be connected to C. Transitive nature for virtual peering is not present. Now we are talking about gateway transitive. Gateway transitive is something different, a little bit different from virtual network peering. Gateway transitive, we can define in gateway transit, we can define some BGP rules, and with the help of BGP rules, this non-transitive nature can be converted into transitive nature. So, for example, we have VNet into our cloud, we have VNet into our on-premises environment, we have another VNet into the cloud. We can make this VNet as a gateway transit VNet. So if this VNet is connected to this one, and this VNet is also connected to this one. And if in the BGP protocol, if it defines special kind of rules, then this VNet can connect to this VNet by through this one. So this is called gateway transit. One more important point here, overlapping address spaces not allowed in peering. That means, let me give you an example. If we have one VNet of 10.10.10.0/24, this is the address space for this VNet 1. Now we have another VNet 2, and this VNet is having something like 10.10.0.0/16. Now if we have these two VNet and we want to peer these two VNet to each other, peering is not allowed for this. Why? Because the IP ranges here and here are overlapping to each other. Why it is not allowed? What is the backend science behind it? The backend science behind it is, for example, let's see, let's suppose like it is connected. Anyhow, it is connected, let's suppose. So if it is connected and we are going to provision a VM1 here, and that VM1 get the IP 10.10.10. Just suppose like 5. Okay, so now this VM1 is created and it has IP 10.10.10.5 from VNet 1, and it is connected also. VNet 1 is VNet 1 and VNet 2 is connected, and now I am creating VM2, and same thing happened here also. The VM2 also get the IP from these address space. Now if I am going to create any service and want to consume this IP address, then it will be a conflict of IP, because there are two VMs in this peering model. There are two VMs having same IP, and then it will be a conflict, and that's why overlapping of IP address in the peering is not allowed, strictly prohibited. Okay, so that's why overlapping is not allowed. Let's go to next step. Now we have two type of connectivity. One is the VNet pairing, another one is the VPN gateway. So for us, which connectivity we should prefer over another in what kind of requirement? So here in VNet peering, it connects two VNets. So that means one VNet peering can connect two VNet, while one VPN gateway can connect multiple VNets. So it connects two VNets. Traffic routed in Microsoft backbone. Microsoft backbone means private network. The traffic cannot go outside of your Microsoft backbone. It is not going to the public internet. Nobody from outside of your Microsoft Azure cannot connect to your VNet. It is inside Microsoft backbone. Low latency and high bandwidth. Of course, because Microsoft backbone is the fastest possible network present in Azure to transfer your data. So since your traffic is communicating inside Microsoft backbone, automatically you will get low latency and high bandwidth. There's a limit of number of peering in VNets, so only 500 peering can be allowed for per VNet. Pricing for VNet peering is ingress and egress. Now here maybe you get confused, what is ingress and egress? Ingress is traffic coming towards Azure. That means if I'm going to copy data towards Azure, I'm sending data from our on-premises environment to Azure network, Azure storage account. That is called ingress. That means data is coming inside Azure. Egress is I'm copying data from Azure to our environment. That means data is going out of Azure network. That is egress. Data coming inside Azure network, it is ingress. Outside, egress. So we have to provide money. We have to pay for ingress as well egress, both charges, if we are going to get VNet peering. Also, we already discussed about non-transitive nature. Sorry, there's a typo. Non-transitive nature of VNet peering, and also VNet peering is very fast. If you can create two VNet in some click, maybe it will take 30 seconds or maybe 1 minute. You can set up VNet peering between one VNet and another VNet. It can be your local VNet where you can create both the VNet in the same region, or global VNet peering. That means you have created VNet in different areas, different locations, and you want to set up peering between them. That is also very fast. Now let's discuss about gateway, VPN gateway. So connect with on-premises and the VNet. That means VNet peering is connecting only with VNets, that means Azure VNets, but VPN Gateway is allowed to connect from your on-premises environment as well, which is very good, which is very important, because in current scenario, we are in the phase of middle ground. That means we are not 100% cloud enabled and we are not 100% on-premises. So we are in the middle. So this VNet gateway peering is very important right now. Maybe after 5 years or maybe 10 years, when we are 100% cloud enabled and our all the resources are running in cloud, then maybe possible VPN gateway will fade away. But right now, VPN gateway is very important because our half of resources are running in on-premises environment and half of the resources are running in cloud. So this VPN gateway provides connectivity from your cloud virtual network to your on-premises virtual network. Traffic uses public internet. This is a small drawback which can be changed by different technology. I will discuss that part also. So traffic which is going toward Azure and coming from Azure uses public internet. Limited bandwidth with encryption. So since we are using public internet, definitely the bandwidth will be limited. But there is a plus point here. We can use our own encryption there. Even though encryption is also there in VNet peering as well, but that encryption is provided by default by Microsoft. But here in VPN Gateway, we can choose our encryption key, IPsec encryption, to encrypt our data. In VPN Gateway, one VPN gateway is allowed per VNet. When we will discuss about the gateways and I will give you demo on gateway, then also we will discuss about why it is allowed only one VPN gateway. There is only one subnet can be created in each VNet which can hold gateway. That's why it's one VPN gateway per VNet. We will discuss it later on. Now coming to the pricing. In VNet peering, we have to pay for ingress as well as egress, but here we don't have to pay for ingress. That means I want to send millions and millions of records to Azure totally free, no problem at all. But if we want to copy a data from Azure to our on-premises environment or any other cloud environment, we have to pay. We have to pay for that. We've already discussed about the next point, can be transitive. We have to define VPN, some kind of protocols over there, and then we can make our VPN gateway transitive. Sorry, VPN gateway setup require at least 30 minutes approximately, because whenever we are going to create a gateway in Azure, normally it will take around 20 to 25 minutes. When I will give you demo on this gateway, I will show you that thing. I cannot show you the whole time, like 20 or 25 minutes. I'm just opening my video in front of you and you're waiting for it. But yeah, in time lapse, I will show you. It will take more than 20 minutes to create a gateway for a. So this is all we have discussed today. And now in the next session, we are going to give we will discuss about the demo, and we will perform some hands-on in Azure. Thank you.